see if we could pull the GCF out before we do the throwback method. 6, 13, and 2, we can't pull the GCF out of that, so we're just going to jump straight to doing the throwback method. You know, this is just something that I call it, you know. So we're going to take the 6, throw it back, and multiply it with the 2. So we get x squared minus 13x. 2 times 6 is 12. Now it's just a regular trinomial with the leading coefficient being 1. So we could jump to our parentheses, put our x's there. Focus in on c, which is 12. You have 1 times 12. You want to see all the numbers that will multiply to give you 12, add and subtract in a way to give you negative 13, right? So you got 1 and 12, you got 2 and 6, you got 3 and 4, and I think that's it. So this guy is, let's see, 1 and 12, would they add or subtract in a way to give me 13? Yes, they would. Because if you added them, you'd get 13, right? The other ones, you'd never get to 13. So the first one, we got the lottery on the first one. So it's 1 and 12, right? This last term is positive. What that could mean is 2 positive numbers got multiplied together. The last 2 numbers where you multiply together when you FOIL. 2 positive numbers could have multiplied together to give me this, or 2 negative numbers could have multiplied to give me this. In our case, since this guy's negative, it was the 2 negative case, right? Because negative 1 times negative 12 is positive 12. And if you added these, if you combine the like terms on the middle term, you get negative 13x. But we're not done, because we did the throwback method and we multiplied by the 6. Now we have to divide by the 6 on the constants, on the numbers. If it doesn't go in evenly, you bring it back. So it's 6x minus 1. If it does go in evenly, great. So that's how this would factor. I want you guys to give this a shot. Pause the video, see where you're struggling or whatnot, and I'll go over it with you. Okay, so leading coefficient, that's what we're going to put our focus on first. If it's 1, great. If it's not 1, we'll do the throwback method. But whatever suits you, right? I just like that one. It's the most convenient. So it's not a 1. So we're going to see if we can pull a GCF out first before we apply the throwback method to it. So 9, 12, and 4, there's not a number that goes into all of them. So we're going to skip the GCF and jump straight to the throwback method. So we want this leading coefficient to be a 1. Since it's not, we're going to take this 9 and throw it back and multiply it with this 4 here. So then we'll get x squared plus 12x plus 4 times 9 is 36. Now our leading coefficient is 1, which is awesome. So we can just jump to our parentheses, put our 2 x's there, because when we FOIL that, we'll get that back. Focus in on c, which is 36. I just like to list out all the numbers that go into 36 before I start thinking which one, which one it's going to be. You know what I'm talking about. So it's 1 and 36, that would give me 36. 2 and 18, that'll do it. 3 and 12, that'll do it. 4 times 9, that'll do it. And 6 times 6, that'll do it. I can't think of anything else. So everything's a positive here, correct? So I don't have to worry about it. They're both going to be positive. If everything's positive there, you don't have to worry about it. We looked at that case. We know that's where they're both going to be positive. So I don't have to worry about that case. Now, you want to put your focus in on the B now, which is 12. You want to see which one of these add or subtract in a way to give you 12. Not going to do it, not going to do it, not going to do it, not going to do it. This will do it, right? 6 plus 6 is 12. All the other ones, you could go through them. It won't happen. So 6 plus 6 is 12, and 6 times 6 is 36, right? So it just happens that this time they both turn out to be 6. We haven't had a case like this before, but you could have the same number. not done because we did a legal move, multiplied the 9. Now we have to balance for that and divide by the 9 on the numbers. Reduce the fraction. 6 over 9 is the same thing as 6 2 times, and 3 goes into 9 3 times, so that reduces to 2/3. Which means that this also reduces to 2/3 because it's the same thing. Then we said we're not going to work with fractions if it doesn't reduce to a whole number, right? 2 over 3, not a whole number. So we're going to bring the 3 back. We're also going to bring this 3 back because that's not going to give us the whole number. So then we are going to get 3x plus 2 and 3x plus 2. And that's completely fine. That's the answer. Just want to simplify that a little bit further. You notice that this is kind of like the same base. So when you have the same base, what you do with the exponents is you add them. So if you want, this is not necessary, but you could write 3x plus 2 squared as your final answer. So here's our last example. I'm assuming you gave it a shot. Let's put together everything we learned today and apply it to this last problem. Except factoring by grouping. So the leading coefficient is not 1. So we're not going to just jump straight to the throwback method or the slide and divide method, which is something else they call it. I forgot to mention that. But it really doesn't matter what they call it, right? As long as you know how to go about doing it, the procedure. Alright, so if the leading coefficient is not 1, you want to see if you can pull out a GCF out first. Factor out a GCF before you do the throwback method. So let's see, 4, 58, and 28. It looks like 2 goes into all of those numbers. So 2 is the GCF. So as far as the numbers are concerned, I'm going to pull a 2 out before I do anything. So this is the first thing we learned in the beginning of the video, which is the GCF, right? So we get something like this. This 2 is not important. We know it's just going to keep, we're just going to keep writing it on the outside. So our focus is on this inside part now. And our leading coefficient is still not 1. It's a 2, right? So now we're going to apply the throwback method to it. We want it to be a 1. It'll be more comfortable for us that way. So we're going to take the 2, throw it back, and multiply it with the 14. Like I said, they also call it the slide and divide method, because I guess I just slided this 2 over, multiplied it, and you know, at the end we're going to divide it. So if that's a better way to remember this method, slide and divide, throw back. I've even heard it being called the baloney method. So. But who cares, right? So 2, and then you get x squared plus 29x plus 14 times 2 is 28. Alright, now our leading coefficient is 1, which is great. So we get 2, open up 2 parentheses, put an x here, put an x there, 28. When we do that, we focus in on our C now, right? Which is 28. We want to see all the numbers that would go into that, which is 1 and 28, 2 and 14, 7 times 4. Alright, see, these are all positive here, right? So that means I don't have to worry about the signs, right? If it's all positive, you just put pluses there. We looked at that case. Now the 28, which one of those would add in a way to give me my middle term, which is 29, right? The only one that looks like it'll work is 1 and 28. This guy right here, right? That's the one that'll work. So we put a 1 here, a 28 here. This is a plus sign. But we're not done, right? Because we brought this 2 back, multiplied it with the 14, which is just ambiguous. So now we have to account for that by dividing the 2 on the numbers, right? So you get 2. If that doesn't go in evenly, you bring the 2 back, so you get 2x plus 1. If it does go in perfectly, evenly, 2 goes into 28 14 times. So that would be it. If you're given this expression and asked to factor, this is what it would be factored as. So thanks again, and I hope to see
soon.